Good morning, everyone. My name is Nick Keller, and today I will be talking about boosting developer productivity building AI apps. I'm a senior software engineer on the Azure Kubernetes Service engineering team, and my specific team is AKS Automatic and Deployment Safeguards. So as Pradeepa mentioned, Kubernetes has a large amount of options and capabilities. However, there are still some challenges to Kubernetes adoption. The amount of choice and flexibility can be overwhelming, and it also means that there's a steep learning curve. How do you make informed decisions with so much information to consume? How do you answer questions like, how do I scale? What open source projects should I use? Options and capabilities are great, but they are not providing value if you are not using them. You could hire someone, but people with this expertise are in high demand. There's also additional cost to ramping up new people. You may have to get them up to date with Kubernetes skills, but you also need to spend time training them on your environments and DevOps processes. To address this, we created AKS Automatic, the easiest Kubernetes experience for developers and operators. AKS Automatic, the easiest Kubernetes experience for developers and operators. AKS Automatic is built to simplify running Kubernetes by coming pre-configured with best practices for networking, compute, and security, as well as abstracting away all of the configuration knobs. So this will let newcomers who are frequently overwhelmed by Kubernetes to get started quickly without having to worry about configuration. AKS Automatic also has safeguards in place that prevent and in some cases solve many of the common workload configuration issues that result in reliability or security problems. Like I mentioned, AKS Automatic comes built in with deployment safeguards, which is now generally available. Beyond image security, following Kubernetes workload best practices hasn't been any easier. With deployment safeguards and built-in Azure policy integration, you can enforce best practices for your Kubernetes deployments through Azure policy. And coming soon, pod security standards support. So we'll allow you to enforce the Kubernetes pod security standards on top of the deployment best practices that safeguards already enforces. This allows you to add multiple levels of security to your cluster when appropriate. This ties back to what Pradeepa said about secure by design. Also coming soon, safeguards for add-ons and extensions. So we'll support AKS add-ons and extensions, allowing safeguards to enable best practices for that add-on or extension when we notice it's enabled. The first add-on that will get this will be AKS application routing. So with the growing adoption of AI, we need to make sure that we're following the best practices for AI and ML deployments now that they have become first-class workloads on AKS. Like regular workloads, AI inference tuning and RAG can be equally vulnerable to misconfiguration as well as configuration drift. These pose a unique set of challenges in production environments. You need specialized compute, observability, model weight portability, and intermediate storage, just to name a few things. Best practices should also be enforced on AI and ML deployments to help 1, reduce overall compute costs or idle GPU resources, 2, monitor and optimize inference performance, and 3, standardize your models to iterate quickly. So AKS standardizes how AI inference and tuning and training works. On AKS, your workloads are declarative. You define inference jobs in Kubernetes native YAML. They're optimized with GPU and node affinity scheduling for performance. They're observable with integrated logging, metrics, and job status. And they are versioned. Model versions and inference logic can be managed as part of your CI/CD workloads. So let's talk about how Kubernetes on AKS accelerates AI innovation and drives real business impact. We all know that faster AI innovation leads to greater business outcomes, but achieving that speed and scale requires the right infrastructure. So that's where we come in. AKS automates and streamlines the entire AI development and deployment lifecycle. Your teams can test, evaluate, and iterate on models faster, leading to quicker insights, smarter automation, and ultimately, faster time to value for your AI investments. It also helps with scalability and future-proofing. AI workloads, like model tuning and deployment, are very compute intensive. Kubernetes dynamically scales resources up or down based on demand. That means your systems perform optimally today and are ready to handle growth tomorrow. But it's not just about performance, it's also about cost efficiency. Kubernetes helps you avoid infrastructure waste by managing cloud resources like GPUs. You use only what you need and when you need it. So you reduce idle time and you save significantly on infrastructure costs. Finally, one of the biggest challenges in AI is moving from prototype to production. Many projects stumble at this stage due to inconsistencies across environments. Kubernetes solves this by enabling consistency, reliability, and automation from lab to production. This reduces errors, accelerates deployment, and ensures your AI solutions are robust and scalable. So whether you're just getting started or scaling up your AI operations, AKS provides the foundation to innovate faster, smarter, and more cost effectively. One of the main tools enabling this is Kaito, which is now generally available on AKS as a fully managed experience. So Kaito is an operator that automates your AI and ML model inference or tuning workload into Kubernetes cluster. It simplifies the process of deploying AI models by bootstrapping the necessary GPU infrastructure to serve the models, pulling the models as container images, and setting up an inferencing endpoint that your apps can talk to in lieu of a managed service. Kaito does a lot of the work behind the scenes to set everything up for you to run AI models, and it does it all natively through Kubernetes CRDs. With Kaito, you're not locked into a rigid stack. You get the flexibility of Kubernetes with the intelligence of AI native automation. Build, tune, and deploy your AI models your way. You get end-to-end AI workflow automation. Like I said, you can seamlessly manage your data prep, model training, fine-tuning, and deployment. It's optimized for AI performance and portability. It's built to run efficiently on GPU-enabled clusters, enabling your scalable AI workloads across hybrid and cloud environments with ease. And it has built-in integration with popular AI frameworks. So it natively supports tools like PyTorch, TensorFlow, Hugging Face, and a lot more, so your teams can use the best tools without a complex setup. For those of you that want an experience with a UI, the AKS extension for Visual Studio Code delivers this. It's the first UI for Kaito, replacing raw YAML with a guided click-through experience. In just a few clicks, you can create a Kaito workspace, select an open source or a custom model, and configure GPU resources. No manifest required. The VS Code experience comes with a built-in playground that lets you test prompts and inspect responses instantly, while integrated log streaming surfaces inference events and errors in real time. The UI proactively checks GPU and model quota and alerts you before deployment, so it prevents failed launches and saves you on troubleshooting time. Kaito also provides fine-grained inference metrics out of the box with the VLLM runtime. So VLLM is a library for language model inference and serving. It surfaces key system performance, resource usage, and request processing for Prometheus metrics that you can use to evaluate your Kaito inference deployments. These include latency, throughput, GPU utilization, and error rates. So this lets you have immediate insights into performance bottlenecks and improved reliability by identifying and resolving issues faster. So these metrics can also be imported into Prometheus and Grafana, enabling teams to build dashboards and alerts tailored to their production environments. Kaito can also be used with Headlamp. So Headlamp is a user-friendly Kubernetes open source UI focused on extensibility. Out of the box, it provides dashboards to view your Kubernetes cluster workloads, configurations, and metrics. To add in functionality, it has a plugin gallery where we have deployed a Kaito plugin, making it simple to install Kaito on existing cluster, browse from a dynamic model catalog that is being updated. You can deploy and manage models, viewing workspace properties.
For this demo, I'm going to show the end-to-end flow for a Headlamp plugin Kaito in the perspective of a user. So first, I'm going to open up Headlamp and check out the plugin catalog. Here, I can search for Kaito and install it using one click. I already have it installed in my Headlamp, so I'm just going to navigate straight to my cluster. For demo purposes, I'm going to use my Mentors cluster. You can see your installed plugins on the sidebar here, so I'm going to navigate to Kaito. By default, it opens up to this workspace page, and this is presented as a tabular overview where the user can see all their workspaces in their cluster in a glance. This row displays key status indicators such as ready, pending, or fail, and this makes it easy to track the health and resource consumption of each workspace. Currently, I have one workspace in my cluster, and to verify this is live, I can head over to my terminal and run kubectl get workspaces. And what we're seeing aligns with what's in Headlamp. I can also filter out my workspaces by namespace, and this is fetched live from my cluster as well. And I can verify that real quick. And it aligns with what I'm seeing here as well. Great. The next tab here is the model catalog, and this is a list of the Kaito supported preset models. I can filter these models by provider company, let's say Microsoft, for example, or I can also search for the specific model that I'm looking for. For example, let's say 5.4 mini instruct. Let's say I want to deploy this model to my cluster, so I'll hit deploy, In the first dialog that pops up, you have the option of node selection. Now, if I'm a new user that doesn't care too much which node my model gets deployed to, I can just skip past this step and deploy my model right away and hit apply. But let's say I do have a preference. If you have a larger LLM model that you know will take up multiple GPU nodes, you can specify how many nodes you want to deploy your model to here. You can also filter specific GPU node types, and it'll fetch the available nodes with those criteria here. Let's say I want to deploy this model to a specific GPU node, and that creates this preferred node field in the workspace CRD. Now I'm going to deploy this model, and you can see again the preferred nodes field here. Now I'm going to deploy this model. After a few seconds, it'll give me a visual indicator that the model was deployed. Now I can see the newly deployed 5.4 model here. Now I can run kubectl get workspaces again, and it lines up with what we see here. Great. So I can now click into each workspace and inspect its status and conditions, including the node that I had deployed this model to. This typically takes a few seconds to get up and running, so I'll come back to this in a second. Okay, now that we see that it's running, I can now chat with the model that I just deployed. So can send it a quick prompt. And from here, I can also configure the model chat settings, specifically the temperature and max tokens. The temperature controls the randomness of the model output, and max tokens is the maximum number of tokens or words that the model will generate in its responses. Some models also support tool calling abilities. Currently, it's just the llama models, and I'll demonstrate that next. So we have a page here that's dedicated to chatting with your model, and I can choose which model to chat with. And it'll fetch me a list of running workspaces in my cluster. I'm going to chat with the llama model to show you the tool calling abilities. So with any large language model, this model has limited information and may require additional context for some user prompts. So for example, if I prompt it to list my GitHub repositories, it'll tell me it doesn't have access to GitHub information. This is where MCP comes in. So MCP, or Model Context Protocol, is a way to call on external servers to provide AI models with contextualized information. For example, I can connect my model to the official GitHub MCP server. This MCP server offers a remote server that can be connected using this URL via a streamable HTTP transport. And this MCP server in particular also requires an API key, in this case, my GitHub personal access token. And now I'll add this server. So now if I were to ask the model the same prompt I did earlier, it'll be able to respond with this information because it has additional context that it didn't have access to before. And during the conversation, you can always add more MCP servers, including those that are running locally in your machine. And you can also disable and enable MCP servers if you know which context you need versus don't need and want to save some time that it takes to call on the tools that it's calling.
So I am pleased to also announce the new agentic AI command line experience for AKS to intelligently manage and troubleshoot your AKS environments. It's currently in private preview. It's Azure native. It's built into the Azure CLI AKS extension to be compliant with Azure RBAC and authentication, and it's extensible and flexible. It's built on the open source agent Holmes GPT, and users can bring their own approved LLM providers such as OpenAI, Azure OpenAI, Anthropic, or any other open source LLM model. There's a specific focus right now on troubleshooting Kubernetes and AKS issues, but we've consistently heard customer feedback that troubleshooting on Kubernetes is hard. So we've started with that use case, and we'll expand to broader CloudOps and FinOps as well. The agentic CLI command is available as AZ-AKS agent through the Azure CLI. The capabilities that we support today are bring your own API key for the LLM. You get interactive mode as default, so that agent will remember your conversational context and you can iterate on investigations. It has an extensible model format. Like I mentioned, it supports all the popular AI providers. And it's fully integrated with the Azure ecosystem for access to any configured Azure monitoring, such as managed Prometheus and Container Insights logs. The CLI also has more than just access to AKS. It can also read any attached resources to your AKS cluster, such as any underlying compute, storage, and networking. It's secure by design. All data stays within your client and your own LLM endpoint, and we do not store any data on the AKS side. The agent can only access data which your user credential can access. And it's custom built for AKS. AKS experts have written runbooks for troubleshooting common issues, such as upgrade failures, node not ready, and DNS resolution errors, which ensures an accurate and comprehensive diagnostics experience. You can also bring your own in-house runbooks and additional monitoring data through third-party and open source providers like Datadog and Prometheus to enhance the agentic capabilities. Speaking a bit more about our roadmap, we're looking to public preview in early September, but here's an extensive roadmap of the features that we're looking to introduce before then. Like I mentioned before, CloudOps and FinOps, support for Azure billing and cost management integrations to help you break down your AKS cluster costs, support for multi-cluster and fleet investigations, which is great for applications that are deployed across multiple clusters, enterprise controls for data privacy and very limited write permissions if needed, as well as a developer experience, generating manifest files based on your application's needs, deploying services and apps to your cluster, and debugging applications. So for those of you that wish, you can scan this QR code and fill in the form here with your email and subscription ID. The AKS team will follow up with you on how to install and use the preview version of the experience.
This is a quick demo of the agentic CLI for AKS Experience. You can access through the CLI using the agent subcommand in AKS. This works for all the common LLM providers including Azure, OpenAI, and Anthropic.
Here, we start with a quick summary of the options in the experience. As you can see, you can ask questions in natural language about any AKS cluster through the AKS agent command. The LLM configuration is through the model and the API key parameter. You can also set these up in a config file.
Now we're going to walk through a real-life use case of this agentic CLI experience. I have a set of shopping cart pods running in the KubeCon demo space, as we will now see. Developers report high latency on the services, and we will try to find out what's causing it and how to fix it. We will start with a simple question about the number of pods running in the KubeCon demo namespace. We see that it can use a bunch of data sources such as Kubernetes, AKS Node Health, and the Internet. In this case, a simple kubectl call will do the job. Now, I am going to show you a few cool features. First off, the last command. This gives us the exact call made in the last iteration and the response received. Next, I want to show you the context command, which gives me breakdown of the available context and the usage of different tools. Now, I am going to ask about the usage and limit of a shopping cart pods to find out why there is high latency. We can see that it finds the right set of tools and provides a summary of the usage. Here we can see that the usage is 300 millicores of CPU and minimal memory. Now, let me ask about the limits. We can see that the usage is close to the limits, which might be reason for throttling of the services. To investigate further, I ask what kind of autoscaling is configured on the service. It tells me that horizontal pod autoscaler is configured and that the current number of pods is the max pods. Now, I ask further to decide what are the next steps for me to mitigate the throttling. It gives me a list of suggestions including increasing the CPU limits, adjusting the HPA threshold, max pods, and various other suggestions. Now, I might want to do all the investigation back and forth this way and let the agent do it all by itself, and that is enabled by Runbooks, which does it all by itself. Please give this a try by signing up and share your feedback.
So, but what if you have a strong affinity for Claude Code or VS Code or some other agent for your workflows? How then can you intelligently interact with your AKS cluster and supercharge your day-to-day tasks with AI? Well, for that, I'm also pleased to introduce the AKS MCP server, now available in public preview. The AKS MCP server allows you to unlock intelligent automation by standardizing and streamlining the way AI agents interact with your AKS cluster. The AKS MCP server is fully open source and available on GitHub. It has unified built-in tooling for cluster management, which I'll talk about in a little bit. There's seamless integration with all supported transfer modes, such as standard I/O and streamable HTTP. And it also enables AI agents to investigate your AKS clusters and dependencies with tooling that reaches beyond the core AKS resources and includes Azure networking and compute. The full list of tools is available on the open source documentation, but to give you some idea of what it can do today, it services tools to AI agents such as cluster management, so you can view your cluster details and perform lifecycle operations such as create, update, and scaling. There's monitoring tools built in, so you can pull historical metrics and logs data from Azure Monitor, Container Insights, Log Analytics, and Application Insights. And there's also networking tools, so you can inspect your associated networking resources such as VNets, subnets, route tables, and more for managing and troubleshooting your complex network setups. And again, it's fully open source and it's maintained by members of the AKS engineering team. So we're always looking for feedback on the overall experience and any requests for tools or capabilities that you don't see. And if you want to leave any feedback, please feel free to open up a GitHub issue. It's right there, Azure/AKS-MCP. Please open up a GitHub issue if you have feedback, and the AKS team will get back to you there. The AKS MCP server also has one-click setup with your local Visual Studio Code using the AKS extension. So all you have to do is download the latest version of the AKS VS Code extension and then search for AKS Setup MCP Server in the VS Code command palette to add the MCP server to your configuration file. So you will automatically get all available tools ready to use by GitHub, Copilot, or your favorite AI agent.
As you can see in my VS Code, I already have the AKS MCP server configured and it's running. There are 17 tools available in this AKS MCP server. If I click into here, I can look at all of these tools that are available. This includes what we mentioned earlier, such as the monitoring, network resources, operations, and inspector gadget. You can learn more about each tool by hovering here, but in this case, I'm going to keep them all on. So they're all going to be enabled for my GitHub Copilot to use. Now let's get into the investigation itself. I start out with a pretty high-level prompt. My customers are reporting connectivity issues to my application, which is running in the block DNS cluster. Can you help me troubleshoot and resolve this issue? And based on the name, you can already tell what the issue might be, but in this case, I want GitHub Copilot to investigate and point out the root cause to me. So now the investigation will start. You can see that it starts pretty high level, and it'll tell you at each step what it's investigating and also which tool it's going to be running to get the data it needs. All of these tools that I'm using today are going to be from the AKS MCP server, and it's going to help us get information about things like application pod status, load balancers, core DNS pods, and other services in your AKS cluster. There's a lot of steps that it's going through here. I won't get into all of them, but I'll just point out some of the most interesting tools that it ran during this investigation. The first one that's pretty interesting is that we have a tool, kubectl Diagnostics, that allows you to test DNS resolution from inside of your pods. It does this by execing into the pod. In this case, I have a pod called DNS test, and then it's doing an NS lookup of google.com to see if that pod can access this endpoint. In this case, it was able to access it, but this is really useful to help see if the networking issue is isolated to just a few pods or just a few endpoints. Continuing down, we get more into the deeper level investigation where we're running inspector gadget. So Inspector Gadget is an open source tool which allows you to get lower level observability into your cluster. In this case, we're using one of the gadgets for observing DNS traffic. So we're doing a DNS trace across the cluster. So we started this trace, and then we'll also generate some traffic to see what's happening. And it's going to help me compile all this information and analyze it at the end. For the sake of time, I'll scroll down to the end to see what is the root cause that was generated based on all of these tools and all of the analysis performed by the GitHub Copilot agent. So here at the very bottom, this is what I'm interested in. What is the result of all of these tools and all of this data collected, and what can I do to fix my issue? So the first root cause that it points out is that I have some DNS blocking templates configured in my core DNS. These templates are blocking connectivity to this internal.cloudapp.net endpoint as well as reddog.microsoft.com. It's returning this rcode NX domain, which was caught by Inspector Gadget earlier. And so this could be one of the root causes of why DNS is failing. Scrolling down here, it also found that there was a network policy in the default namespace, which is blocking API server egress. Now, this is very concerning to me because API server connectivity is very important for pods to be functional in my cluster. It's blocking egress traffic to this endpoint, which is captured in the DNS traces, and it's definitely related to either DNS infrastructure or API server. So as a summary here, which is what I'm most interested in seeing, what is the root cause? The root cause here is that there is a network policy which is blocking egress traffic to this IP, which appears to be a critical DNS or API server component. DNS queries are failing or timing out when they need to access this IP. Applications are experiencing intermittent connectivity issues, and some DNS resolutions are succeeding, but others may fail. And this may be why my customers are reporting that there are sometimes connectivity issues to my cluster. It also shows me the evidence from the DNS traces, the network policy, which it can access through the MCP server tools, and then also how the application seems to be performing normally, but my customers would still report connectivity issues. And finally, getting into the recommendation. To resolve this issue, you should modify or remove the block API server egress network policy, and this should ideally help clear up the connectivity issues in my cluster. I will stop the demo here, but I could continue and have GitHub Copilot help me modify or remove the network policy to fully close the loop on resolving this issue.
Okay, cool. Thank you all for listening to me talk to you. So now I'm going to hand it over to my colleague Ria, who will be talking to you about AKS security.